Hi, my name is Justin. I am the Salmon Watch Coordinator and Riparian Specialist with Mackenzie Watershed Council. And today I'm going to talk to you about, guess what? Riparian zones. What is a riparian zone? So normally at this time I would ask you all to think about this wonderful language we call Latin, but we won't quite go into that right now. I'm just going to break it down simple for you. Do you remember when you were knee-high to a grasshopper and you used to go out bowling? What was something that you noticed in those lanes? Usually some kind of bumper or a rail. And that rail keeps your ball from going into the gutter. When I think about a riparian zone, the way that I like to think about it is that all these plants, all these communities of plants, provide a buffer between the upland forest, which behind me would be that hill you see, and the aquatic zone, the water. Pretty simple stuff, right? So all of those plants, all of those communities of plants, the soil, the microorganisms that are working in there, all help to create a buffer and protect this water from what's happening on, say, that road. So there are specific functions that riparian zones provide, not both to the fish and the organisms in the water, but also to us. The first one that I like to talk about is shade. So in order to actually imagine what's happening here, you're going to have to dig into that brain of yours and imagine that you're a raindrop. And you're in that cloud, and all of a sudden you need to come towards the ground. And as you start falling, one of the first things you're probably going to encounter here are going to be these trees. And what do these trees do? Well, as that water falls, the branches slow it down, allow it to disperse slowly to the ground, and then based on gravity, it's going to start to make its way towards this channel. Now, if I have good soil, and ideal garden soil is 45% mineral content, 5% organic matter, 25% air, and 25% water. That water will make its way down. All of this vegetation will slow it down, allowing it to percolate into the soil. And then as gravity pulls it to this aquatic zone, these trees will help to regulate that temperature. Now, when I say regulate, it's not going to make it hotter, it's not going to make it colder, it's going to help to maintain the temperature. Why is this important? Well, things like thermal pollution can have really negative impacts on those fish. So all this shade that we see helps to regulate that temperature, so as these salmon make their way up the stream, they have enough things like dissolved oxygen to make their trip. Another function of riparian zones, and probably one of my favorites, is filtration. And the way that this works is pretty amazing. The way that I kind of like to think about it is in a Star Wars sense. Symbiotic relationships. So what ends up happening in places like Alaska, British Columbia, where you've got a lot of bear and a lot of salmon, those bear will go up onto the hillside, or come down from the hillside, I should say, down into the water. They'll grab a salmon. Then they bring it up onto the bank. Because they have so much salmon and they only want the good stuff, they eat the brain and the belly, and then they leave the rest. Well, now I've got this this fish that's starting to break down. And all those nutrients that it brought back from the ocean start to enter into that soil. And then you get an exchange where I have these microbial communities and these microorganisms that will go and collect something like nitrogen. And they'll bring it to the plant and they'll say, hey, here's some nitrogen. The plant's super happy because that's food. But the plant produces a sugar that it then gives to the microorganism. Both organisms have eaten. They've gotten the energy they need. Together, they work together to help maintain this environment. Another cool thing that can happen though, is let's say that it's a salmon that's breaking down and part of that salmon ends up being absorbed by that tree, by that plant in an area that we call the Rhizosphere. As that tree starts to grow, I could come back 20 years from now, take a DNA sample from the very top of that tree, and guess what I'm gonna find? That's right, whoever that was that said that, you are right. Salmon DNA. You are what you eat. So not only will these plants help to filter and clean the water before it makes it into this main stem, it also provides another really cool benefit. And in order to help explain this, I need you to think about Minecraft, for those of you that know what that game is. So, if I'm playing Minecraft, let's say that I have a block of redstone, and I want to remove all the sides from it. What am I left with? A good way to put my art degree to use. Now, That's not the most perfect cube, but I think you get the idea. Even though I've removed all the sides from this, I could still set another block on top of it, because the structure and stability from that block doesn't come from the sides, it comes from that frame. In that same respect, if I look out into a riparian zone and I imagine all the soil is gone and the only thing left are the roots of the plants, it's the roots of the plants that actually provide structure and stability to those banks and help to mitigate the effects of erosion. I say mitigate because erosion is a natural process. That's how some nutrients and minerals get brought upstream down into those ag lands that do things like corn that we love. At the same time, too much of a good thing can be bad, and those roots help to hold that bank together and keep it from falling off and rolling downriver. The final function that I want to talk about in a riparian zone is habitat. And in order to understand this, you're going to have to use your imagination again. I know we're asking quite a bit of you, but I'm pretty sure you can do it. So I want you to imagine that you're a bird and you live up in Canada. Now normally when you're out here in November at Whitaker Creek, it's not hard to imagine what it's like to be cold. But if I'm a bird up in Canada and it starts to get cold, am I going to hang out there and freeze my tail feathers off? Or am I going to head down south for some fun in the sun? Yeah, probably going to head down south for some fun in the sun. So I got to fly from Canada down to, say, Mexico. Am I going to be able to do that in one flight? Probably not, unless I'm stuck to the front of a plane. But if I am, I have other issues. I'm going to need someplace along the way where I can stop, eat, get food, maybe even have little babies. So if I imagine a big green highway going down from Canada all the way down into Mexico, and I'm standing in Alton Baker Park in Eugene, Oregon, what happens if I remove all that vegetation off the river? Well, it's kind of the same as creating a big hole in the road that they need to get home. So I start to lose habitat. At the same time, if I'm out here on the water and you look behind me, you'll see some trees have fallen. Those trees, if I'm a small salmon, as that tree falls down, it helps to slow down water. The faster water moves, the more it carries. So now I have gravel coming, it hits the log. The log slows the water down, the gravel drops. The water makes its way underneath the log and around because water always wins. But now I have this nice pool with gravel, and if I'm a salmon and I'm looking for a nice place to spawn, that's perfect habitat. At the same time, when I'm a baby and I've got stuff above me that wants to eat me, underneath that log is a really good place to hang out. So when I think about habitat, imagine there are approximately 412 known species in Western Oregon. 413 if you count Sasquatch. I haven't seen one, but I'm not judging you. Of those, over 80% spend all or part of their life in a riparian zone, including us. Finally, I would like to give special thanks to Lane ESD, Oregon Department of Fish and Wildlife, Bureau of Land Management, and all the volunteers that helped to make Salmon Watch possible. Again, Justin with Mackenzie Watershed Council, I hope you enjoy this.